We have now taken a look at two agentic tools authored by Anthropic. So let's now spend some time to reflect on how they work and use that knowledge to better understand what agents are all about. First, I want to review Claude Code. I went back to our small project and gave Claude an additional task. I asked it to write out some tests for a particular corner case. Claude then used a series of tools to fulfill the request, and I've shown the entire log for this operation on the screen. Now, out of all these different tool calls, two were used to read existing files inside the project, one was used to write to a file, and one was used to run a test. Now, I'd like to think critically about each of these different tool calls and what they were meant to achieve. In other words, why did Claude decide to use each? Well, three out of the four tool calls were really intended to gather information about the environment. By environment here, I really mean the codebase that Claude was operating on. The one remaining call was intended to modify the environment in some way. We can see a similar pattern with computer use. When I asked Claude to test out that mentioner component, Claude made a variety of different tool calls. Just so you know, the computer use tools automatically return screenshots. So if Claude attempts to type or move the mouse, it'll immediately get some visual feedback of the environment. So as we examine the tool use of Claude Code and computer use, we start to notice a pattern really quickly. Both of them are using tools, and these tools are largely focused on just delivering or getting information into Claude. Let's summarize some of this tool use inside of a table and use it to better understand what agents are all about and what really goes into making a successful agent. So in both Claude Code and computer use, we're going to see that they share a wide variety of different qualities in how they work, how they run, and how they are getting information into Claude. Both these make use of tools extensively, and they both run tools inside of a loop until some goal is achieved or until some unrecoverable error occurs. They both rely upon tool calls as their primary source of information about the environment, as opposed to relying upon some kind of RAG process, or relying upon a developer to write out a super detailed prompt, or relying upon a user to write out extensive instructions. They're both given a very small, very focused set of tools, where each tool has a very clear purpose. Finally, they are both intended to work on high-value problems, where failure doesn't cost much money. In other words, Claude is writing code, which is traditionally a very high-value task. It takes a tremendous amount of knowledge and experience to write effective code. At the same time, if Claude makes a mistake in the code it generates, there's not necessarily an immediate, inherent economic or safety impact. Compare this to Claude, say, building a complex design for a bridge, where an error could have a very large safety impact. In summary, when we consider building an agent, there are a few concepts we need to keep in mind. First, an agent is a language model that has access to a set of tools and is being executed repeatedly until a goal has been achieved. Second, context is king. Claude doesn't have any knowledge of the outside world at all, and it relies entirely upon being given a set of tools to inspect the environment. Third, we really want to think about using agents only when we have a high-value task where an error or failure won't have a large economic or safety impact. And finally, the best way to make sure you are building an effective agent is evals. Creating some evaluation criteria and evaluating your agent against it is the only way to ensure that you are making an effective agent.